All right, welcome back, my friends, to ProfessionalVMware.com's vBrownBag US. We're in the What's New in vSphere 6 series. This is Virtual Volumes Part 2. Last week we didn't quite finish our Virtual Volumes discussion with Rawlinson, but this week we're going to kick it up a notch and finish it off and hopefully have a good deal of Q&A as well, because I know everyone live is itching to ask those questions again. All right, so just to get a few things out of the way, obviously we have a number of brown bags. Select your time zone, select your feed, whatever you would like. Follow us along, #vBrownBag on Twitter. I will be fielding questions to Rawlinson as we go. Rawlinson, how are you today?
I'm quite excellent and late as usual, but I'm doing great.
Yeah, all right. Well, look, you're upkeeping tradition. That is the main thing. I'm not going to introduce you like the Stig this time because, quite frankly, I was late myself and I didn't have time to think of anything. But you are like the Stig, and I'll just leave it at that. So thank you for coming on. Let's let's take up from where we left off, which I believe was SPBM.
Yes.
So I will make you the presenter, and I will let you take it away, good sir.
All right, so let's see. Let me hide some stuff here. I don't want you guys to kind of see what's going on in the background. I don't want to get fired. But yeah, so can you see my screen now, Nick? Can you see the screen? I don't hear you. I can't hear you. I just hit share.
Yeah, man, I can
see
hear
anybody.
Yeah, sorry, I was on mute. I muted myself. I did a Josh Atwell.
You did it again, rookie. But I get it. It's cool. All right, folks. So I think we left off last week when we got into the whole concept of our storage policy-based management. So before we kind of get into the whole situation pretty deeply, let's kind of discuss a little bit about what is it that storage policy-based management is working with and how all these pieces come together to the things we discussed last week. And the more questions you have, please start firing away immediately so we can take this and make it more of a conversation instead of a slide deck presentation. So 2 things to get out of the way fairly quickly. We deal with storage capabilities, which storage capabilities are obviously what they are. Capabilities are presented or features that come from an array, right? Obviously, we know a lot of these capabilities, as you see here on the right-hand side, are represented in the form of snapshots, deduplication, replication, quality of service QoS, and all of these different things, where in a storage infrastructure, we tend to create, design, and architect array systems to deliver those particular type of data services, but at the level of a particular LUN, those particular containers per se. And obviously, based on the conversation we had last week, everyone now understands the concept of a storage container. When compared to a traditional LUN, how different they are and how they're managed in some of their similarities, but the things that they actually that make a storage container much more valuable and different. And it's because of this thing here, this capabilities, it can actually now be exposed from the array to an individual object or an individual virtual machine, and it can deliver that selective and granular control if you wanted to, so that we can actually deliver better performance and capabilities on a per VMDK level, right? Which is really important. Obviously, this sort of technology comes about by leveraging our vSphere APIs, and to be more specific, the VASA APIs, where now we have this 2-way communication where the array can tell us, when I say us, meaning the vSphere infrastructure, tell us what capabilities it has to offer. Now, the vSphere infrastructure will also be able to communicate back and say, this is what I want to consume from what you're offering. So because of the 2-way communication that exists between that implementation, we're able to actually get what we want and how the whole policy concept comes to play really nicely. Now, out of all the different capabilities that may be available and features that may be available from a particular array, the way in which we combine those capabilities so that they can be consumed in the vSphere stack is through what we call VM storage policies. So there's a construct within vSphere which allow you to save these capabilities and these values of those capabilities into one single construct that can then be utilized on a virtual machine or on a per VMDK basis and be sustained that way. Now, that is what the storage policy-based management framework consumes. That's what it looks at in order to then request the type of data services and the actual storage capabilities that may be needed on a particular application. Doing that, this illustration you see down here below is how the array in this particular case is able to place the object in the container and in the place that will be able to deliver what is being asked for in this particular VM storage policies. This framework is something that it works with virtual volumes because it's part of our software-defined strategy, but this also bleeds into virtual SAN. And virtual SAN was the initial technology which delivered this sort of approach and capability, but now we're exposing it to the rest of the ecosystem so that everyone out there, all the different vendors and arrays can leverage this capability and be able to use policy-driven frameworks for the management and consumption of storage.
All right, before we go on,
now,
I have a question for you before you go on. So if you just go back to the other slide, you've got all these amazing policies that are going to automate stuff. Now we've already got some automation with storage DRS. How does that interact? Graham Mitchell's asking, how does storage DRS work with virtual volumes?
Graham Mitchell's trying to stump me again? That's a good question. So the way we look at some of that automation, so think about the core of what that's doing. So storage DRS is a way of managing a form of contention, right? So I look at it similar to what I look at regular DRS, which is a contention mitigation strategy, as I look at it, where this is a capability that allows you to define movement of a workload based on some performance characteristics, right? But that is something that exists at the vSphere level. And the reason why I say that is an excellent question is because notice that one of the things that happens in that particular model deals with moving data from one line of data sort to another. And that is exactly what we're trying to mitigate and kind of avoid with this new strategy, because moving data around, it is beneficial in the sense that you will eventually get what you need, or you avoid a potential problem. But there is a very expensive operation when it comes to moving data around dynamically in such way where obviously we all know what happens when you're moving VMDKs, depending on the size, depending on the time, depending on the infrastructure supportability and bandwidth capabilities. It could take time. There could be some risks and impacts just simply to satisfy the requirements of that particular item. So when you look at the capabilities that are being offered through a system today, I can tell you that they're not focused around data mobility in that sense. We're not looking at storage DRS to expose storage DRS as one of the capabilities, because number one, SDRS is a vSphere capability, not an array type of capability. We look at some of the values and characteristics of the array to make decisions up in our stack. But again, that is a vSphere level operation, right? Where particularly now what we're doing with virtual volumes, we're looking to obviously offload a lot of these functions, a lot of these management tasks directly to the actual array, so they become a bit more efficient, faster, and deliver better services all around. Hope that answers that question.
Yeah, that's good. All right, one more question before you move on. And there was a question from last week from Graham. What about VVols support with Power CLI? I did not ask Alan. I forgot, but I hope you did.
Our good pal, our number one vSAN champion when it comes to automation, Alan Renouve, my man. I can honestly tell you that we have not implemented any sort of virtual volume specific Power CLI commands, but we do have policy-based management commands. We able to do certain things with the commands, but they're more applicable to maybe virtual SAN. There's some aspects of SPVM that can be managed through Power CLI, because remember, the policies apply or are applicable to virtual volumes and virtual SAN as well. So there's some things you can do there, but we're not there yet in terms of Power CLI, and I expect that to be done soon. And maybe we can catch Alan on the side some point here and kind of maybe send him a couple of tweets, and he'll probably respond to that.
Yeah, quite possibly. All right, so just going back to that previous question around storage DRS, Graham's follow-on question is, so the array would auto-tier as usual on the back end behind the virtual volume if needed?
Yes. So this is a hot question because everyone, we're all accustomed to this traditional, what I would call hardware-defined data center strategies, where we deal with moving blocks, we're moving data. But obviously, there's two concepts here. Where there's a notion of the array does it itself, and let me use an example of one that I'm somewhat familiar with, which obviously is EMC's the VNXs and their platform, which they use fast, right, which is auto tiering. I can tell you that, and I hope I don't get in trouble for this, but I can tell you that those capabilities that are exposed from the array perspective, they will continue to work in the same way. Whereas what you will see as a capability will be fast, probably from EMC in that case, right? Where you can enable a particular object and say, I want it to reside in a fast mega or whatever they call those mega volumes, where the same functions could still happen as they're being offered to the array, right? But they're not susceptible to vSphere related type of features, particularly per se on storage errors. And as a matter of fact, storage DRS is not supported with virtual volumes today, right? It is something that would eventually get there as a probably a roadmap item, but because when we're looking to deliver the same performance, data service requirements, and all the different capabilities and application and object needs, the concept in virtual volumes and the storage containers is that those containers should be able to satisfy those requirements. Because when you think about it, think about what we talked about last week. A storage container is, for lack of a better term, a wrapper on top of all these different pools that you have within your array. And it lets you say, within all of these different pools and things that I have in this array, I can make all of these capabilities function from within this one logical construct. So if you have to change the profile, change some capability, it should happen within that container without it having to move. Now, do storage vendors have the ability to deliver such capabilities? Absolutely, because this is entirely up to them to do. But it basically depends on the implementation of that. So some of the stuff might be already happening under the hood, right? But SDRS, for example, for this initial release of virtual volumes, will not be able to achieve what we achieve with traditional VMFS lungs.
Awesome. Thank you, sir. No other questions?
Any more questions?
That's all we've got at the moment.
All right, so let's move on because you were cutting off, you were chopping off somehow. All right, so here's that example on how these capabilities are exposed. Obviously, and just to be more specific, you can see those capabilities being expressed, obviously, and advertised through our VASA provider. This is a big thing, right? And virtual volumes introduces a new generation of that VASA, of the VASA APIs, which is what delivers that two-way communication that exists today. Previously, when you use, because VASA is not new, there was VASA 1.0. But when you think about the way we configure VASA compliant arrays to vSphere, you basically went through what I think used to be called like storage profile something. I forget, it slips my mind. But it was a one-way kind of configuration where, yeah, you can see what the array has available, then you can consume it in such a way in vSphere, but it was still very statically defined. Right? You didn't have the flexibility because that exists today, because you still, as an administrator, had to place the different VMDKs or the objects where they needed to be. You just at least knew now what kind of capabilities were able to be were offered by that array, and alleviated some of the risks that were taken by placing things in the wrong locations. So we can expose capabilities per array, per container if it's supported by the platform. This is major. This is very, very important to understand. Some implementations of virtual volumes, depending on the vendors, may or may not be able to deliver multiple storage containers. Now, the notion of having a single storage container represent an entire array sounds really nice and very good, because we no longer have to worry about managing multiple loans and volumes and all that stuff. It's just one, and everything works. But you also may want the ability to not have what we call a conform or formalized type of container configuration, where maybe you're looking into having separate storage containers because each one of those offers different policies and different capabilities, right? or not policies, different capabilities from the array. Maybe you want to enable on one container the replication capability, while the other container has snapshot and encryption, right? So you want to be able to select different types of capabilities and assign them individually and keep them in such a way, where it's important to understand that not all implementations can do that today, right? Some are able to deliver the value of virtual volumes by giving you the ability to only have one container. Others allow you to do that and deliver multiple containers, but at the same time, some implementations that can give you access to multiple source containers may not allow you to deliver or configure different capabilities on a per container basis, which means that you can have multiple containers, but what's available within that implementation in terms of capabilities will always be available to both. And there, the approach you take to consume it and manage it will be, because you now may want some sort of logical isolation from a security standpoint, where you may not want an admin of a particular business unit or department to browse the container that belongs to maybe the HR department and be able to maybe potentially map VMs that he or she shouldn't be mapping to, right? So the implementations in what's supported within the arrays is very important, but they're entirely up to the array vendors themselves. So it's very important for you guys to kind of be aware of that, so that you can ask the right questions to your particular vendors and what they're delivering and what their capabilities are.
Okay, cool. So you might want to do separate containers for multi-tenancy or security or something like that. What about, can you mark like a storage container as like read-only? Like, you know how you can do read-only mounting of NFS data stores, that kind of thing? Is that one of the capabilities within that we can present?
No, not, to be honest, not something that I'm aware of. And again, I've seen a lot of most of the implementations of virtual volumes, and that is one quality that I haven't seen or identified yet. Obviously, you know, within vSphere, we do have the ability of providing read-only capabilities to the different virtual data stores, and obviously there is a one-to-one mapping between a storage container and a virtual data store. But that is, again, from an administrative standpoint. So to your point, that could potentially be achieved at that level, but not necessarily at the level of the actual container, depending on the implementation again, right? Because if the implementation is not based on block, and it might be NFS, we also have, remember, we have the ability of providing read-only access to when we map them up in the vSphere stack. So that becomes a very interesting approach where obviously these things still work the way they do, but from a capability perspective, from you being able to see that up a level, you won't, because this is something that probably a storage admin will be able to control, and that will probably happen on their type of management framework, and instead of the virtual volumes in vSphere framework itself.
Cool. All right. I will let you continue, sir.
All right, cool. So here's, for example, some of those things that we all know exactly, all the different types of capabilities that these array solutions can deliver. And then just think about it, being able to selectively choose them and consume them on a per virtual machine aspect. And the way that sort of is reflected in vSphere, it's quite simple. So here's an example of the wizard that you will see whenever you have a vSphere 6 implementation that has access to a virtual volume VASA provider. And keep in mind that this is very specific here, because you may be able to have and support multiple providers within this particular infrastructure, but the capabilities and policies that you build are based specifically on those particular systems. So here, for example, this is something that I created. We have the ability of creating these software implementation of what it will be like in an array, right? So this is internal, so we keep everything very kosher with everybody. We don't show any kind of favoritism or anyone here. So I created this appliance and exposed these capabilities manually myself, right? But notice that in terms of the vendor-specific capabilities, they come from the vendor provider you choose. If you have a NetApp, if you have a Tintry, if you have a Pure Array, if you have an EMC, whatever you have, it comes down on this down arrow here, and then the capabilities that will be presented to you are basically the capabilities that are exposed on the array, and this is coming up here via the VASA or the vendor provider where that communication is surfacing up those capabilities so that you can selectively choose them and utilize them as a form of a policy. Now, each one of those capabilities may have different values, right? Some of them are very simplistic, yes, no, whatever. Some of them may require or expose, when it comes to backup, for example, a schedule, right? And different things that may be implemented depending on the vendors. One of the things that I did this morning, if you guys didn't get a chance to see it, is that I participated in a webcast with Hitachi, and they showed some really, really cool capabilities. And one of them that so far no one else has been doing it, no one else has implemented it yet, which is a cost value in terms of the capabilities of the different types of their system, how they're consuming, because something that customers wanted. So that's taken it a little bit above and beyond the just the technology metric, but now exposing operational and financial impact to the way storage subsystems are consumed in the form of a policy, which is very, very powerful. So again, it's just a matter of being able to, for a vendor to expose what they want through this framework, and if it's exposed, you'll be able to consume it. The beauty of this, and one of the things that I always profess about virtual volumes, is more than just a technology. We've had storage technologies for forever, and regardless of the product and the implementation, everyone always has their own twist and their own value. But at the end of the day, storage is storage. Now, how do we improve upon the consumption, management, and operation of storage? Is that now with SPVM, you basically have a management framework which is defined based on a policy architecture that not only allows you to provision and deliver the capabilities and the performance service levels you want for a particular volume or VMBK or VM, but it also helps with the life cycle of the virtual machine by being able to track whether or not the requirements of a particular object or a particular virtual machine are in compliance or not, right? Compliance means basically are the requirements that I have defined in a particular policy being satisfied where this virtual machine or object currently resides, right? So when you have a number of failures to tolerate per se, a particular performance value, a particular rate capability, a particular protocol that you may want to use, if it's not being satisfied, the system actually checked this. So instead of an admin having to actively be on the console or have third-party tools or integrated tools which have maybe 5, 10, 20 different minute intervals to identify compliance or not, you can basically see this, right? And we will surface up alarms and let you know when these things are not in compliance. So you can go through hardware recycle scenarios where, again, now the system will be able to help you track the consistency and the actual compliance of the performance and values that are to be delivered for the individual components. Now, this happens automatically during a particular time cycle, but you also have the ability of validating and checking compliance whenever you want out of cycle by basically clicking in the UI, and you can see there it says check compliance in the event you change things. Now, one of the biggest impacts, and I think the aspect of one of the bigger, more valuable aspects of virtual volumes is the administrative efforts, right? So we obviously have two different management workflows that everyone from the storage admin to the vSphere admin should really get accustomed to an understanding on how this works so that we have a pretty good way on how to manage, monitor, and consume this infrastructure and then communicate with the different parties and identify when there's a problem, how do we go about it. So obviously, it's a very similar process in terms of management where everything starts with the storage admin. The storage admin will normally gain access to its management interface. It will have the ability of defining the storage containers, being able to identify the capacity, enable the storage capabilities that it may want at that level, right? From that point on, a vSphere admin now can go into the vSphere web client in order to consume and map a particular storage container. You will go through the wizard which says add a data store, right? A virtual data store now has three options, NFS, PMFS, or VVol. Once that's selected, hopefully at that time, you have already created storage policies because number one, doing any of the provisioning operations for vSphere, whether it's going to be from a template, new, copy, whatever, whatnot, you're now always going to be prompted or have the ability to add a policy to the different VMDKs that you may have within that operation. So it's important to have the policies already predefined ahead of time when you come to that point. And then once you add you have access to the policies, you can proceed and add them to the actual virtual machines and their VMDKs. Once the VMDKs and the virtual machines are going to be provisioned, now that's passed on down to the array itself. And you can see now where the storage admin will now be able to see the virtual volumes, right? Because now on the array side is where an admin is going to identify these actual volumes. Understand this, from a vSphere standpoint, an admin will never see, and maybe I shouldn't say never, but you won't see today any construct within vSphere that's called vVol, right? You see VMDKs, you see the same files we've seen forever, but on the array side, the storage admin now is going to be able to map those different VMDKs as individual virtual volumes that map to that specific virtual machine, right? And those are the correlations that have to be made. And maybe as vSphere admins, we may have to educate some of these storage admins to kind of understand what that kind of looks like now. But there's also the possibility that depending on the vendor implementation, one in particular here that I have a lot of experience with, which is NetApp, they actually, through the vSphere web client, they're actually let you, as you know, if you have the right access and the right permissions and all that stuff, you can actually create the container, which is mapped into an aggregate, and then within that aggregate you create a FlexVol, and once that FlexVol is created, that's what becomes the virtual volume type of data store, which can then be mapped to vSphere, and all that stuff happens automatically without having to kind of touch and talk to the storage admin. But again, an aggregate would have to actually be created and mapped and made available to that point where still the storage admins have an understanding on how that works. And a lot of the different implementations do that. One of them that I like, as I said before, is a NetApp. Dell in particular has a pretty nice GUI, one of my favorite GUIs when it comes to doing this kind of stuff. It's also very nicely integrated into the vSphere web client, and many of the other partners that are coming up with some of these solutions, which are really cool. But understand what's happening here. It's simplifying operations, simplifying the management workflows to deliver more efficient and more capable and a much more way of implementing our solutions with a lot of reduced risks, which is quite nice.
Cool. All right, I got a question before you go on to this next section. So you talk a lot about the different UIs and the different implementations of what is coming. Have you got any kind of indication on, I mean, this has just come out, right? We know that, and the vendors, other than VMware, we've obviously just given our piece of the puzzle, but the vendors have to come out with their implementations on what fits into that piece of the puzzle, right? Mm-hmm. In terms of average timeframes, I'm not asking specific for a particular vendor, but should we expect product on the market within the next 3 to 6 months, or are we looking 12 to 18 months out before we have, production ready capabilities to use vVols day to day by the storage admins, or at least available to purchase or available to schedule that upgrade of their existing?
So there are some available now, and there are more coming within, the next few months. So there's So all of the partners that were, all of the vendors that were partners with VMware throughout the whole vVol development cycle, some of them obviously knew that we're going to be ready by GA. Some of them knew that we're going to be ready by X number, like 90 days after GA, in the following quarter, right? So I can tell you that the stuff that you guys want and need, it's coming. All of the things that I've said, or these I've seen them. I've touched a lot of them, and it's just a matter of these vendors finalizing their builds and their code and what they're doing, sorting their implementations out a bit more. But when you talk about production ready type of implementation, so that is a question that I like to kind of put back to the audience, right? So what would you consider a production ready type of capability that would allow you particularly as a customer, as a user, to move to utilize virtual volumes in a production environment? So see if we can maybe fish some of that out as a question, Nick. Maybe someone will respond real quick.
I will let you know if I get any direct to that. I guess I can actually kind of answer that a little bit. Brian's saying replication, needs to have replication. Brian Welch. So I did the Silicon Valley VMUG yesterday. Great event. Thank you to any of the listeners out there that were there. It was a fantastic event. You missed out, Rawlinson. Sorry about that.
Shameless plug, dude. Stop plugging yourself. Come on now. I wasn't there.
Oh, you don't ever plug yourself. That's all right.
No.
So what I did was I canvassed the audience in my sessions and just asked them how many people are on which version of vSphere. And the majority of the users that put their hands up were on vSphere 5.5. Now, until they're going to schedule their compute virtualization upgrade to vSphere 6, even if they upgrade their array firmware or the new VASA provider or what have you before that, until they're actually running vSphere 6, they're not going to be able to take this capability and use it. So it's almost like a chicken and egg situation. You've got to have both of those pieces before you're going to see any real world use. But one thing that I'd also asked was, when is vSphere 6 production ready for you? I said, we use it internally at VMware in production. So I would actually say, not just when you answer that question, it's not just the array that you need to consider production ready, or the connectivity option, in this case virtual volumes, but also the hypervisor as well.
Absolutely. The difference between that comment there is that, the minute we GA, we're production ready. We're a production ready type of software deal here. The qualification for that is some of the actual consumers, which obviously a lot of folks wait, until the first update, and some of the things have some of the maybe undocumented features pop up, before the update one, before they move it. But to be honest, depending on the ability to upgrade to a new release, and we all know, listen, in the real world, no one does it the day things happen. That is just not possible unless you're really awesome and extremely daring and a total daredevil. But some of the new technologies that are being delivered with 6.0, or some of the new capabilities and features delivered with 6.0, go beyond technology, right? And when you impact operations, when you have a positive impact on the way an infrastructure can be consumed, which will drive efficiency at all levels of a company, of a business, it may speed up the process to get you there, right? vSphere delivers the goods every single time that it comes out. But obviously, we're running into a hiccup just like every other piece of software in the world. It's a matter of whether or not you could deal with that in the initial process, or are you looking to wait? Can your business still function in a way that it needs to, and can you afford to bypass the operational and some of the other benefits beyond technology that are delivered with the new platform? That's basically the question you have to answer as a customer, and as as maybe advisors, we would communicate that to our customers themselves and see what really matters, right? Because it's like you said, if you want to use virtual volumes, you have to upgrade to vSphere 6. There's no backwards sort of backporting here, virtual volumes. You got to go to 6 and above.
Yep.
Being able to do that and use that, it takes some thinking. It's not just something that could be done overnight. We do that at VMware because we pretty heavily eat our own dog food, as they say, right? And that stuff is developed in-house, so we could do that, but not everybody else is able to do that. Now, when it comes to the one thing that was called out here about replication, so let me try to sort of clarify a couple of things here, and this is when exactly I love when Susie, which was the old virtual volumes PM, I always threw this at her because I didn't want to. I prefer to dodge all the bullets, but let me just kind of take a stab at this here. So we have an official statement on the supportability of array-based replication with virtual volumes. And the statement on that is, today, it is not supported. And the reason for that is, our reason for that is specifically when it comes to the vSphere stack. So whenever we utilize replication technology that requires, for example, SRM to touch things and do the things that it does on these replication type of scenarios, today the SRAs are not capable of communicating with the VASA providers. I think everyone should probably understand that every single operation that happens with virtual volumes goes through the VASA provider. These are API calls that are communicated through that appliance which are then driven down to the array systems for things to then happen. Today, there are no SRAs that can do that. They can do the things that whenever SRM, for example, has to do modify VMX files and all the things that it does. Nothing can do that right now from an SRA perspective. And that's why the stance on the whole replication thing of VMware, it's where we're at right now from an array-based perspective, right? And I hope that that's clear and everyone kind of gets that. Now, we do have support for vSphere replication. Now, obviously, vSphere replication is software-driven. The whole point of virtual volumes is to enable array-based capabilities. Now, these are managed operations that can take place from within the platform, and they're fine. Your arrays could potentially deliver a replication capability under the covers that is unknown to vSphere. Now, the challenge to do that is whenever we replicate these volumes and data, the actual VVols themselves, those IDs that are contained there within their actual metadata and all that information, once they're replicated onto another site, right, they're going to change. And how would you manage and expose those different IDs to an infrastructure that expects one thing but is getting another? Typically, the way we manage that is obviously SRM gets in there and does his magic, and we're good to go. Right? We're able to actually, fail over, fail back, and do all these different things that we can do. But they're plugged into these other orchestrated sort of engines that enable that. And today, that's not available, or we're not supporting that. Just like we're not officially supporting SRM with vSphere replication. Right? And we all know very well that you can use SRM with vSphere replication for many things. It's just that particularly now for virtual volumes, it's not supported because of testing, right? And some other things we have to kind of work through, and it'll be there. So maybe in one of the near updates, we'll get that. But that's the official stance on the whole replication aspect of virtual volume support, because I think replication, when we talk about production, it is a very, very important feature when it comes to production and putting the kind of applications that we use on a day-to-day basis. So it's important to understand the actual facts here, what can be done, in order to kind of sort of understand and know how to navigate those waters. Again, I think this morning, if you attended the HDS session, they are looking to have supportability for that kind of thing that I just mentioned right now, array-based replication, which is happening without the need of SRM and some of these components. But again, that's something that it's a future thing, and it's waiting for validation and all sorts of certification things that has to go through VMware ourselves and even them. But those are capabilities that if your array can do it, they become unmanaged operations. For example, when I say unmanaged, it means that they're not managed through our UI, through our framework. So you, for example, won't be able to see as a capability exposed within SPVM something that says replicate, right? Because we want to make sure it's done on a per object basis and that level of granularity, which is what virtual volumes delivers. And I hope that's maybe clear and maybe address that question. And hopefully by tomorrow, I'm not fired.
Sure. Okay. I have a question here before you go on. Graham Mitchell is worried about SQL and performance. So in terms of, are we going to see performance degradation with this new technology, or performance improvement on the flip side?
Graham Mitchell worries a lot. He has some really good questions.
Yeah, and so he's also saying MSCS support, or I'm assuming is it Microsoft clustering, or are you talking about Windows failover clustering, Graham?
I love it, man. I love it when we just talk about it. Questions are the best things in the world. Let me address that.
All right.
Excellent question. So whether it will improve performance in SQL or degrade performance, tough to answer, to be honest. Number one, because why would you think that performance will degrade? I can tell you theoretically why I think performance could potentially increase, because we're offloading a lot of the different functions directly to the array. The array knows now exactly how to manage and how to do what it needs to do for each individual object. Now, the concern from a performance degradation, I'm not necessarily sure how to go about that, because again, you're using the same array that you were using before virtual volumes, potentially. You're still going to have the same access and capability to do the same things you did in the past. Now you're going to leverage some of the new implementation details. And I'm wondering if your question is driven towards anything that has to do with the protocol endpoint. And I wonder if you could maybe just answer that real quick so I can continue. No answer. Okay, good. So to address the whole MSES supportability, that's a big one, right? So for legacy types of MSES implementation, failover clustering, a lot of our customers are using that. A lot of our customers will not let that go. Even though they don't need to use that in some cases, they won't let it go. It's a matter of education and getting our folks up to speed with the fact that some of the applications that behave in such a way, SQL, Exchange, and some of these others, now have application-based availability built into them. We have the DAG groups, we have the always-on SQL clusters and things like that that leverage all the ways and other features that can be used to deliver the MSES cluster capability. For example, virtual volumes, even though it was an intention and we're working towards it, the reason why you cannot use virtual volumes for these scenarios when it comes to avoiding the use of RDMs and all that kind of thing is because we still do not support SCSI 3-level commands, right? The reservation that we need in order to deliver that capability. And because of that, you're going to still have to leverage RDMs. Now, if you have the ability of changing how some of these implementations are done, and you have one of these applications that can do what I mentioned before, you might be able to do it. Because now, for example, one of the things that Microsoft is doing is supporting the witness, the quorum as we call it, the witness in the form of a file witness, which through SMB 3.0, which is their protocol, you can expose this file as the witness for the clustering capabilities. And you'll see a lot of different documentation from us, particularly the same issue on vSAN and virtual volumes, where we will expose and talk about and walk you through how to do this in today's world. Because it's not only that, but also think about the fact that when you use databases and when you use these mail systems, we're probably accustomed to the way in which we deploy and place the data by separating them between LUNs, right? Logs go in one LUN, data goes in another LUN. The log LUN can give me X capabilities and certain things, while the data LUN can do X, Y, Z as well, right? Now we're moving to a world where all of these sort of characteristics kind of go away because you can still deliver the performance value and the requirements that you may want, but they're going to be stored within the same data store, per se, the same storage container, right? So there's a lot of sort of learning and sort of mind changing that we have to do with our customers. And to be honest, people worry about installing and configuring new software, new releases of vSphere and whatnot. That's not a problem. We could do that 100 times all day, every day, and it just happens. It's not that big of a deal. What is a big deal is whenever you try to introduce change to an infrastructure that it's not all about the technology, but when it impacts operation, which is exactly what this is doing, that is a much bigger impact, and you'll find much more sort of pushback when it comes to that than anything else.
Yeah. I have a question here from Dan Barr. He's saying, in relation to the performance, and you're saying that you're offloading a lot of the requirements from your hypervisor down to the storage array, kind of like VAI. He's saying, is there any extra processing that storage array controllers need to do for the extra layer of mapping vVols to those real block LUN underneath?
Is there any? To be honest, beyond, it's all managed by the VASA provider in the protocol endpoint. So obviously that's part of how things are built. And yeah, that's my little son there. He just gets excited when I talk about virtual volumes.
Of course he does. He's crying about them. He's like, give me more virtual volumes.
He didn't like when I said virtual volumes. He likes for me to call them VVols. He's told me that a few times. But when it comes to and it was a question in reference to maybe, are we increasing overhead or any way, shape, or form, or is there, or are there any more resources that are needed in order to accommodate these new capabilities?
Yeah, that's the question.
Yeah. Okay. So no. To be honest, and to be a little bit clear there, the offload capabilities are similar to like what you said. Similar to what VAI delivers. Now the thing is that and I've written a couple of articles on the whole management of VAI against vVols. So vVols has its own set of primitives, which are unique to itself, and it's the default operations that are chosen. And in a sense, it's similar, right? But there's different operations where, and whenever they take in place, whether depending on the implementation, whether they work or not, we can pass them down to VAI, and it's the same level of sort of interaction. So there's nothing extra from that point that it's needed in order to adhere to the new sort of primitives that are available. We're good?
Yeah, we're good. I've got questions coming in thick and fast at the moment. So just a comment. One comment saying it's great to see that vVols will support the thin reclaim unmap trim directly from the VM OS.
Oh, let me add something to that. That's awesome. Who said that?
That was Burhan.
Awesome. Someone knows. But here's the deal. Virtual Volumes natively supports that. Now, whether or not you can use it depends on the vendor's implementation to choose and leverage that. I know a couple of implementations that do not leverage that, right? While it is available in the vVols framework, these implementations are not, as part of their implementation, these vendors were not able to add that to their implementation. I don't want to say names because I don't know if I'm supposed to say that, but let's just keep everything really cool. But the fact that you guys know that, and now I just kind of gave you a little bit of that where, yes, it's great, but not everyone has it implemented. So for those of you that are looking into use virtual volumes, this is an excellent question to ask your vendor, unless, someone from my team or myself exposes that in a blog at a later time.
Well, go on to expose it.
Dude, come on, come on.
There's another question from Brian saying when SQL performance came up, you asked if the concern was around PEs. What if there were a concern around the PEs?
Well, I can tell you that the chief, also known as Duncan Eppen, lit a fire under my a few weeks ago. Because he brings up, the guy does what he does, which is bring up some extremely valid points and some things that we may overlook and maybe discuss it. So when it comes to the whole queuing aspect of in performance, right? This is all dealt, the multipathing and all the different things we're dealing with related to performance. It's now handled at the PE level, right? So it is very important for us to have an understanding of the ability from in the performance capabilities that an array can guarantee on a per PE basis. So the concept is that we have the ability of having a much lower number of virtual data storage containers, but we have an increase in the ability to have more protocol endpoints of multiple protocols, multiple types whenever needed. And that's how we manage potentially delivering better queuing, because obviously one protocol endpoint could be just a choking point, but it depends on what the number of virtual volumes that a single protocol endpoint can address, and at the same time also the number of containers that it can address and what the performing value and characteristics are there. So obviously being able to have multiple protocol endpoints can address some of those concerns, but yet again, I don't want to sound like a broken record, but it's not up to us, right? So those performance characteristics are going to be defined and implemented based on the array. So whenever an array vendor says, we can support up to X number of virtual volumes per X number of containers with one PE to satisfy X number of IAPS and those calculations that we do on a per LUN per basis, that's how we approach them, right? And a lot of that information comes based on the vendors and the arrays that you have, and you should be able to get that information directly from your vendors.
Cool. That is all the questions. Continue.
Awesome. Love it. All right, so let's talk about provisioning and the lifecycle workflows of virtual volumes and what happens. So obviously there's a couple of parties that are involved here. Let's say that from a storage perspective, all the work has been done, right? And I don't want to mislead anyone here, and because one of my graphics, and because virtual volumes is so conceptual, understand that here you see 3 different storage arrays with 1 source container across all of them. Not happening, right? That's just me, my poor illustration of this. It should have been 1. You cannot do that today, but we will in the future. So let's say that everything's already configured. Now when it comes to the vSphere admin, it's ready to create virtual machines and assign those different policies that have been created that are suitable to that particular container. And you can see here how it maps to that virtual data store. Now, whenever a provisioning operation is done, right, whenever some of these requests create vVol, these functions will be directly offloaded to the array via the VASA provider. Right? So these are basically VASA API calls that go into the VASA provider, which are then given to the array, and it says create vVol where and what it needs. Right? Under the cover, all of these different operations will happen, will take place, and then we'll take into account the policies that are being offered from vSphere. Now, if you want to decouple this whole thing, think about this. You can think about this as a somewhat of a translation level, where a VM storage policy is maybe it's a file that has information about what the storage array can do, and once the storage can read it, it's able to say, okay, I'm going to put this here, this there, and this there, right? And that's how it's translated, but it all happens in the background. Now, how do we maintain access to these different virtual volumes, to the objects that are created? So there's these operations that are called binding operations, and there are multiple types of them. So basically, when you talk about what these binding operations are, it's an operation that coordinates the data path between the VASA providers, the ESX hosts, which are accessing those particular virtual volumes, right? And that's what actually dictates who owns what, when it's what, and between IDs, and all of those different things. Here are the 3 different mechanisms that exist today. You probably won't see this, but it's important for people to know and understand how this works. So the one, when it's called binding operation, basically allocates and creates that one channel, the I/O channel, for the particular virtual volumes. When it comes to an unbind operation, unbind means potentially destroy. For example, saying delete this virtual volume, it basically eliminates the I/O channel between the host, right, in that particular volume, so that it's no longer mapped. These operations happen and take place, particularly, as I said, when you're deleting volumes from within a particular array. Or they could also be a rebind operation. So a rebind operation basically provides a chance for the protocol endpoint to to run on any given virtual machine at any point in time, depending on what's required and what changes. Maybe there is a change in the path, there's a change in the protocol, there's something that changes as part of that operation that it doesn't necessarily have to either create or begin to bind or unbound or bind something, but basically because it's there, you're able to rebind it, right? And for example, deliver the same connectivity to the same VWall that's available there. So these things take place. These operations are part of the life cycle of a virtual volume, and kind of this logical illustration here shows you kind of what that process sort of looks like in terms of being able to rebalance and access multiple paths and all those different things. So this is actually what's happening as part of those different operations under the hood. These are things that you do not have to worry about. You want to be aware of them, but you don't actually get to control how these things work.
Just go back one slide. We've got a couple of questions on that.
Mm-hmm.
So is the binding kind of like mounting and unmounting? I mean,
yes.
It is? Okay.
In a way, right? Because the binding is what allows you to communicate with a particular virtual volume, right? So it's sensitive for me to say mounting and unmounting, because mounting in vSphere, when you say that, it's similar in that way. But here's another aspect of a volume. There's the behavior where there's an active-passive behavior with volumes where you will find that volumes are bound when they're active, and you may also be able to see volumes that are unbound when they're not active. And what that means is, for example, when there's communication going through that I/O channel, things will be bound, will remain bound. When there's not, they'll be unbound. And I think there's a slide here. Let me see if I can quickly show you an example of that.
So Thomas Larocque has actually said, so we have no control over that binding process. There's no nerd knobs.
There are some knobs, but not really exposed. We do some things in the background, but in the surface, you guys can really access that. So for example, here's that screenshot I wanted to show you. If you look here on this is why I love this Dell UI thing, because it kind of helps me show folks and explain what's going on here. See that right now this virtual machine has one VMDK, and as it is turned on, I think we discussed last week, every virtual machine at the lowest level of its configuration has a minimum of 3 virtual volumes by default. It has a config VVol, the data VVol, and the swap VVol. The swap VVol becomes available when the VM is turned on. But look at the snapshot. If you look all the way to the right to the status, you see that it's unbound, which means it's not active, right? While the other 3 are. So let's say, for example, you wanted to revert back to that state on that particular snapshot, then there will be a rebind in there, in that operation. And then you will see that the status of that virtual volume as active, right? That's the kind of thing that happens in the background. Now, the question to you guys might be this. So you asked if there's any knobs. Now, what knobs are you looking for, and what would you like to have?
That was exactly what I asked. What do you want to see? What do you want to play with?
Because remember, when you want to get into that level, you're now introducing risks. You're now somewhat getting in the way of the value delivered by the solution, which is simplicity. And the minute you start playing with knobs, we're talking complexity, right? And then while it'd be very valid to do that, you want to think about doing that very carefully, which is why now a lot of the things that we do in the systems that we deliver and in the solutions that are delivered are good to go from the beginning without having to tune things like we did in the previous years in vSphere to get things going with, with NFS, with VMFS, and all those. We want it to be as good as it needs to be out of the box and reduce the complexity of managing the system, which is one of the big principles of this technology, the solution today.
All right, I got 2 more questions before moving on to operational scenarios. In the case of contention, when you've got all VMs to be high-performing VMs, and the array runs out of fast storage and has to move some VM decays to slower disks, who decides where it goes, the vendor or the VMware-initiated algorithm?
The VMware administrator, or it could be the vendor if they have a solution for that. And let me tell you specifically why. So when you have a performance problem, whether it might be because of capacity, it might be because of queuing, it might be because of any of the performance characteristics are not satisfied. Today, the virtual volume framework does not use any logic to per se remediate or self-heal that problem right there and then. Because as what I said before, we're looking to reducing the requirement or the need to move data around. That is a major thing, right? Obviously, there's value in that always, but that also comes with risks, and it's one of the things we're trying to mitigate. Now, you will see that when a certain level of a storage service or characteristic level is not satisfied, that is part of a virtual machine's or an object's particular policy, it will fall out of compliance, right? Now, when that fall out of compliance happens, it is, an error not only is surfaced directly in the UI, but an alarm will be surfaced through the stack, and then someone will have to act on that to remediate that problem. Now, I can tell you that, and I don't know if you guys heard this morning at the HDS sort of talk, where they actually have something that could potentially do that. I don't want to kind of go out of bounds here, but essentially that's our goal. That's what we look to do: facilitate the ability to remediate when a policy is not in compliance, and by remediation meaning we can move it to another storage container, to another location that can satisfy the requirements of that policy. But you got to see and understand how complex that is, right? Because remember, if you have dissimilar capabilities on different storage containers, if there's something in the system that looks at that, something should tell you not in compliance, right? Where I can't move it. So now we leave it up to the actual human factor, administrators, to actually go and do that. Now, if you want to see something like that working, so last year I built a plugin that probably some of you may have heard known as what I call Project Magic, which is an integration piece between bringing SPVM into vRealize automation, where I've built logic into this plugin so that instead of placing VMDKs on individual LUNs and individual data stores that are presented in the service catalog, you can consume the infrastructure through different data services and requirements that you may want per object, right? So while you do that, the system will completely abstract any knowledge whatsoever of the underlying supported stored infrastructure, and based on the data services that you choose and pick and the policies that you've created in vSphere, the system will place them where they need to be, regardless of what type of array they are. As part of that implementation, I also included a day 2 operation that basically says, if today I deploy my application and it landed an XYC array and an XYC whatever, which who really cares, tomorrow I'm expecting some sort of boost in the system access because of month end or maybe Black Friday's coming. I want to change the requirements of my application. And when you change the requirements of the application, I mean a policy, my plugin will do the following. It has a logic to look into where the current object currently resides, and it'll ask sort of the questions of, can this container or storage device satisfy my requirements? If not, who is? When it finds the suitable data store that can satisfy the reservation, and it could be dissimilar systems, dissimilar capabilities, then this plugin will automatically storage vMotion the objects or the VM entirely to that location based on those policies, right? And that's actually something that will potentially end up in the framework for virtual volumes as we kind of move on to the next release. But you can do this today with that plugin, but within virtual volumes itself, you have to basically, that manual factor is still there. You have to, choose to move the actual VM and components in order to satisfy the different things.
Okay.
We good?
Yeah. We've got questions, so you can't move on just yet. So Graham's got a question around. He said, so what about metro storage clusters? And I said, well, wouldn't you need replication for that? And he's saying, so no active arrays?
So that's a good question. And today, I'm glad, you guys are asking all the right questions. And I can tell you that, so metro cluster comes, there are few players in the game that do that today, right? NetApp, EMC. And if you were on the webcast this morning, you saw that HDS is also aiming to do that. And obviously, replication is the way they look at it is not necessarily always. It's based on the way they implement it, right? But when it comes to the replication piece, obviously that's a big requirement. And because of the limitations that you now know today, and some of the hurdles that we have to overcome, implementation of metro clusters for virtual volumes may not be available from every vendor, may not be available from everyone, because that is a very vendor-centric implementation that goes beyond what vSphere in virtual volumes are offering out of the box today as a managed operation for this framework, right? But it's possible. It's out there. And then I would suggest, if you're asking that question, I would suggest if you missed it this morning, take a look at the HDS replay of the session.
Where can they find it?
I would actually maybe just look on Twitter today, look at the history, and just do a search on HDS presentation, this webinar this morning. I tweeted a link this morning when I said like a couple hundred people attended. There's a lot of that.
Go back through your feed.
Yeah, or the HDS feed, or there's a lot of people that were tweeting that.
Okay, fantastic. All right, and what about storage I/O control? Baron's asking, is storage I/O control supported?
Not in this release, right? And to be honest, I think it was last week maybe that I published, and I think I have a slide here, and if I don't, I'll show it to you guys all. Maybe I'll just jump out of this and just show you I created I posted a blog on the supported features and products for virtual volumes today. And let me pull that up real quick. Hopefully you guys can see this in a second. I'll be able to show you that very effectively here.
Just be careful, you've got your whole screen up, remember?
Yeah, I moved that to another screen. I don't want to get fired.
Yeah, good.
Can't really show these guys the goods yet. So I posted this article here, which you'll find it officially in the VMware storage blog. And here, let me know if you can see this next. Maybe I can make this bigger or something. You think this is visible by everyone now?
Potentially.
Let me see if I can do full screen here on these Mac thingies. Let's see. Okay, here we go.
Well, maybe that didn't actually do much. You need to zoom in. There we go. Yeah, you can read that.
Cool. So here's an example of the features that are supported today. So obviously, thin provision, SPVM, link clones, native snapshots, view storage accelerator, storage vMotion, vSphere, flash recache, vSAN, auto deploy, HA, vMotion, XVMotion, NFS3, and all those things. What are not supported are also listed here, product-wise and features. So storage I/O control, NFS 4.1, IPv6, SDRS, FT, SNPFT, our new I/O filtering sort of engine that's coming, array-based replication, RDMs, and MSCS.
Okay, just go back up a little bit. You're saying that to vRealize operations, the question in here, it's saying it's not supported and not interoperable. So what happens if you've got VROps in your environment and you have a vVol data store or a storage container that's presented as a data store? What does VROps do with it? It just can't collect the counters, or does it break stuff?
Correct. It doesn't collect because it doesn't know how to do that right at that level. But remember, the storage system does. So now the storage admins themselves can see that, and you could see from an individual virtual machine, when you look at the monitoring performance, you can see counters there. But for vRealize operations, and I put manager there, I need to probably fix that. I don't even know if that's the right name of the product, but whatever. It's not there yet, but it's coming, right? So just know this: there's a new management pack that was released and is going to be updated very soon, including something that will support virtual SAN as well. So we kind of, virtual SAN and virtual volumes, when you think about it, they have some similarities when it comes to the individual objects and components, right? So once that's delivered and available, things should probably be a lot nicer and simpler to kind of have that interoperability and supportability in place.
Cool. Awesome. Thank you, sir.
All right.
No further questions.
Okay. Let's go back to the deck. How do I get out of full mode here? Oh, good. Tech support. All right. So we're back to operation scenarios. So offloading, migrations, and snapshots. This is important, right? So one of the things that it's good to know and to sort of be able to understand is how we go from virtual volumes, or how do we migrate from virtual volumes to, from VMFS to virtual volumes sort of infrastructure. And here you see that the migration process is seamless per se, because going from VMFS to a virtual volume, nothing really changes, nothing really impacts the VM itself. Why? Because understand this: while virtual volumes now deals in the space of object store, where now these array systems natively understand this object store type of construct here. Inside of that object, right, where the data and everything kind of resides, VMFS still lives, right? So when we traverse between the different virtual data stores, there's nothing a customer needs to worry about other than I'm going to move X number of VMs and their disk at a time, and so on and so forth. And depending on the capabilities of the array and how you do these migrations, you'll be able to offload some of the operations in that case. So for example, if the VMs happen to be turned off, so the migration from VMFS to virtual volumes can then be offloaded completely to the array in that event, and some of the different operations you may have it. But the process to going from VMFS to virtual volumes it's quite simple. You've done it before, and it's nothing to it other than we follow the same procedure. Whether you evoke it from Power CLI, you do it from the UI, it is the same exact process, and there's nothing different here when it comes to going from one place to another. Now, the questions as to why would you go from one to another depends on what you're trying to what is virtual volumes going to deliver to you in terms of benefits that VMFS is not. And the question that was raised before about production in non-production environment, obviously based on the requirements of some of your applications, you may or may not be able to move them from VMFS to virtual volumes, right? But it is dictated around those kind of capabilities. But in the form of interoperability, is it going to be a conversion or whatnot? No, it is quite simple, and we've been doing this all the time. So actually, I believe that I haven't posted this demo yet, but I created a demo as part of the whole Project Magic product where I display that same sort of operational model consuming from that serverless catalog, but it had VMFS, NFS, vSAT, and virtual volumes, and you can actually see how by simply changing the policies, the VMs were migrated across different types of storage systems, different types of architectures and all that without any problem whatsoever, which basically my point was just to prove the level of interoperability that exists within those products at that point in different cases. So here are some of the operations that are offloaded, right? When we talk about the value of being able to offload some of the capabilities of the array. So the provisioning of VMs, deleting full clones, link clones, snapshots, in storage vMotion. Now, I'll check myself on the whole storage vMotion there. A storage vMotion is not offloaded when the VMs are live, right? If they're running, it's not offloaded. This is offloaded when the VMs are powered off. So I want to make sure that everyone's very clear on that, because I myself have identified a bit of confusion with some folks in the field and even internally around this particular capability here. And a good example. So, the question obviously comes up sometimes. What happens when an array supports VAI, but it's also VVol compliant? What comes into play? What's used first? So obviously, in terms of offloading capabilities and being able to offload the operations, again, it depends on the implementation. Because in this example here, if I'm looking to do a move where for some reason there's and I can't really think of a particular reason why, but it exists. I just can't really pinpoint one out right now. If I can leverage the default VVol primitives, right? What will happen is that the system will look back and see whether we can leverage the VAI, for example, xcopy primitive to then perform a cloning operation or that operation that we're trying to execute as we're moving things around from between VMFS and VVols. So like I said before, one of the things that I noted, someone asked a great question about the whole on-map capability of virtual volumes. Again, it's there, but it's a matter of whether or not the vendor chose to take the time to implement that capability, and if it fit their implementation at that particular point in time. I'm sure everyone wants to leverage that whenever possible. Here's a comparison of that same sort of approach in terms of VI block, in terms of and how it applies to VVols and all that. So one of the things that virtual volumes delivers above, I don't want to say above, but in terms of the similar benefit when it comes to VAI. So remember that when we implemented VAI, in order to offload and do all the different things and all the values that are delivered, we needed for NAS specifically, we needed to install an individual component, right? There was a driver or some sort of thing that needed to be installed on a per array basis. So that basically now kind of, with virtual volumes in its primitives, that kind of goes away, right? Because now we're able to deliver those things natively there, but we also sort of eliminate those capabilities from VAI from a NAS implementation perspective, because now virtual volumes can do that on its own. So when it comes to different cloning operations, if you're cloning within a particular storage container, which is the way you will do it, that obviously takes place within that container. It's offloaded to the array, and the vendor can utilize its cloning capabilities. This is where things are huge, because now we're talking about not coming up the vSphere stack to use our cloning and snapshot capability, but leveraging and using the arrays technology, which everyone has their little different implementation of these capabilities, and the value they deliver is now here exploited when it comes to their implementation and being utilized at this particular level. Now, when you compare that to cloning maybe a VM from a VMFS to a virtual volume container, again, we fall into the model where maybe due to the lack of implementation or maybe compliance with either one of the primitives, whether they're not supported or not, then at that point, maybe the operation cannot be offloaded, and then it has to come up through the stack as it normally does in our world today and managed through vSphere. So a software data mover per se within our stack will then manage that sort of operation instead of being offloaded to the hardware directly on the array. There's a really good article that I posted on this. I get into a lot of details. It's on the vSphere blog. It's on my blog as well, where I do VAI versus VVol, right? And the main concept that I want to sort of drive here is everything defaults to VVol primitives by default, right? The only time any sort of operation within the lifecycle is going to try to utilize VAI, that's a failback sort of mode. That's option 2. But remember that we will try and leverage VVol always, even when the different arrays support both the new VASA providers, the new VVol primitives, as well as the VAI primitives that exist from our previous implementations. Lastly, when it comes to the snapshots world,
I got a question. Yeah. I got a question for you, and it's kind of related to snapshots. People are asking VVols, VM fork, Project Fargo. Now, I've mentioned, I back to them, VM fork is only available currently through private APIs, so it's not something a customer can do. But let's say that we've got a technology that is, or a product that's using those private APIs to take advantage, use VM fork. Can those VMs that are being forked be on a VVol data store?
That is a very good question. One that can get me into a lot of trouble if I answer it. But let's just be real about it. Remember that virtual volumes is about allowing customers get the best out of their current investment. Right? There's a reason why in scenarios they utilize the snapshot capabilities that are available in an array. A vendor may not be as willing to maybe give up their value on their way in which they implement their snapshot technology and give it up to the vSphere stack. They could, they may not be. The whole thing is what I'm trying to say is that there's always a value there, but they have to now, where they have full control of their capabilities on the array level. So what Nick just said, the VM fork today, that's not even available beyond our walls, right? So I think that unless there's an immense value where a partner can leverage this new technology that we're bringing forth, they may not choose to do that because we're still susceptible to limitations within vSphere. And when it comes to snapshots and clones and things like that, you can take a look right here on the slide. It says we have a maximum, right? From within our capabilities, we reach a limit. And even though it's quite large, when you compare that to the limits that are exposed on a particular array, specifically when it comes to snapshots, they could do hundreds, but we can only do 32, right? So it would have to be a give and go kind of situation here. I don't want to discount it because obviously, nothing is impossible. It's just a matter of the right parties and the right people having the same sort of mutual interest and being able to reach some sort of agreement and deliver that for the customers. But I don't know. There's potential. I can tell you, just like Nick said, it's a private thing right now. I obviously don't know when it will be publicly available, if it will be publicly available to expose to, but it's a pretty hot thing, and it's a pretty, it has a lot of value, and I can see why folks would start thinking about, can we leverage that from, leverage that VMware capability from a source perspective, but it's yet to be seen. We're good?
Yeah, we're good, man.
I guess we're good. So, snapshots. So, since we discussed that a little bit, snapshots behave. We manage them and behave. They behave differently, but we manage them in two different ways. Where we all know how a snapshot works, the different implementations of the snapshots, which actually, if you guys want to see a little details into more than what I actually have here, Cormac published an article last week, and he went into a lot of detail into how the snapshot behavior works in virtual volumes, because it's different depending on what to use, whether it's vSphere snapshots or it's going to be the array snapshots. And there's some really good information that you can actually read. Obviously, Cormac writes the best stuff in the world anyways. And he gets into a lot of detail, and if you want to kind of get into a little bit more of the details that I have here, I mean, I would love to discuss it, but I don't have a slide, so I can really address it or kind of think of it right now. But overall, understand that virtual volumes have, they're useful in the way we use them, in the context of snapshots, on how we use it for the purpose of using vSphere. We take a snapshot before patching, before certain things happen, so that you can roll back and forth depending on what happens. But when we're talking about using it on the array purpose, it has the same possibility, but it could also be used as a form of a backup that you can keep for long periods of times, and it can actually be accumulated there. And obviously, without having to deal with some sort of performance degradation and things like that. Because remember, whenever you leverage virtual volumes now, the snapshot technology is going to be based on their implementation in collaboration with some of our stack, if done that way. But you no longer have the behavior that exists with VMFS, where the longer you have these snapshots, the longer the tree becomes, you start seeing performance degradation as a result of using that other file system in some cases, where now this is entirely in the array. This is another value proposition that you can see and understand that comes from the array themselves. The concept of managed and unmanaged, anything that you do through the vSphere stack, as you see in this example here, you see the virtual machine snapshots and you manage them as you see there. That's what we consider a managed snapshot. You manage them from within our VM snapshot manager. Or you can take the approach where it's managed from the array. Most likely with a different virtual volumes implementation, particularly here for NetApp, that's how that's handled. And there's obviously a lot of different values and benefits that could be done there. But in some cases, when you talk about recovering and kind of utilizing these snapshots, the vendors have the ability to plug it in directly into our stack, right? And if they do that, you can still continue to manage things in the same sort of fashion. But the minute they fall outside of our framework, and you have to manage that from the arrays perspective, from that individual array software stack, then it becomes an unmanaged operation. So the process to recover, restore, traverse between different states of a snapshot tree and whatnot will have to be managed and handled outside directly on that particular software. And with that, I think this is, I think I showed you this, guys. I forgot that I had it here. These are the supported features. Some of them obviously there I actually have, which needs to be a little bit updated. But when it comes to identifying the benefits of virtual volumes, this is one of those marketing slides which, to be honest, keep thinking beyond the technology, because a lot of the new features that are being put forth now as part of the software-defined data center and the software-defined storage strategy are not just specifically designed and targeted to storage technologies, right? We're going to reach a point where everyone's basically the same with different tuning capabilities. But the thing that this delivers is efficiency in an area where we've been sort of lackadaisical for many years, and we needed the improvement, which is operating, being able to reduce complexity. And this is what this delivers. It'll take some time to digest, some time to sort of come across the different concepts, but just like everything else when it comes to technology, we always do it, right? The important thing is here, make sure you identify and you can convey the value of these solutions beyond the technology. And obviously everyone's in it. And with that, that's how I do it.
Awesome, man. Awesome.
Oh.
There are no more questions. I think everybody's just, their jaw is on the floor.
Come on, give me some.
Any final questions before we call it here tonight, folks? The mic's already dropped. They're saying no questions.
I can always pick it up. I can always pick it up and drop it again.
Do you know what? I reckon you should have that as an animated GIF.
I thought it was animated. Let me see.
Oh, no, it comes in, but the mic should fall. You should split it in half, and the mic should fall.
If anyone has skills doing that, please let me know. I'll send you this little pic, and if you can make that happen for me, I'll give you shout-outs all the time. Stickers, T-shirts, you name it.
All right, everybody's saying great session. Thanks, Rawlinson. I agree. It was a great two-part series. I'm just going to put the new schedule up. So let me just throw that up. So this is the new schedule. We've just done VVols Part 2. Mike's going to be on next week to talk about security. We couldn't bribe him no matter how much money we threw at him. Josh is going to be on the following week, and then a special May the 4th episode, which is not a Wednesday. All right. We're going to be back to talk about vSAN. I'm expecting that session to go long.
Yes. I have a lot to talk about there.